Okay, let's talk about quadratic functions. And so when you think about a quadratic function, you want to make sure that it has this x squared term in it, and that is nothing higher than x squared, okay? So when you're thinking about quadratic functions, they should have that x squared term in them. So these are polynomials of degree 2. The graph of a quadratic function is called a parabola, and it has this U shape. So this a, the leading coefficient, a, tells you how the parabola is going to look. Is the parabola going to open up or is it going to open down? And so when a is positive, the parabola opens up like this, and the curve reaches a minimum at that bottom point there, which is called the vertex. So the vertex is that bottom point, or if a is negative, the parabola opens down, the curve reaches a maximum at that vertex there. So that's the shape of a quadratic function. It looks like a parabola. Also, knowing more than just how it opens up or down, there's a lot of other features that are useful. That line in the center is called the axis of symmetry. You notice that it passes right through the vertex. It's a vertical line. The x-intercepts are important, the y-intercepts are important. And so let's think about how we find all those features. So the turning point is the vertex, the maximum or minimum of the parabola. The axis of symmetry is a line that goes through the vertex. You can find it with this formula, x equals negative b over 2a. Remember, this comes from ax squared plus bx plus c, the same sort of setup we used for the quadratic formula. The x-intercepts are where the graph crosses the x-axis. To find those, you set the equation equal to 0. The y-intercepts are where it crosses the y-axis. You plug in 0 for x. And then the zeros are the roots. These are the x-intercepts of the graph. It's just another term that we see there. So when you think about a quadratic in the xy axis, there's 3 things that could happen. It could cross the x-axis in 2 places, giving you 2 zeros. It could just touch the x-axis and bounce off, giving you 1, or it could be entirely above or below the x-axis, giving you 0. And this comes from the quadratic formula. Remember the part in the quadratic formula, the discriminant, b squared minus 4ac. If b squared minus 4ac is 0, then we'll have only one real root. If it's a number, a positive number, we'll get 2 roots, and if it's a negative number, we'll get no roots, no real roots. So we're going to find a lot of these things using our calculator, Desmos. So let's try an example. This says, use your calculator to graph the following function on the coordinate plane below and answer the question. So f of x equals negative x squared plus 5x plus 6. So this is a negative, so we know that this is going to open down. Okay, so it's going to look like this. So some of these questions we can answer already. Is the turning point a maximum or a minimum? Because it opens down, the turning point is a maximum. Okay, so I'm going to put this into Desmos, negative x squared plus 5x plus 6. Negative x squared plus 5x plus 6. Let's zoom out a little bit there. So up there is my vertex, 2.5, comma 12.25. Here is my y-intercept, 0, 6. And here are my x-intercepts, negative 1, 0, and 6, 0. Okay, so we're going to use all of those numbers there. So I'm going to put the vertex up here. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There. 1, 2, 3, 4, 5, 6. Negative 1. 1, 2, 3, 4, 5, 6. So it looks a lot like that. Okay, this was 2.5, 12.25. This was 0, 6. This was 6, 0, and negative 1, 0. So what are the coordinates of the vertex? 2.5, comma 12.25. You could also find that using the x equals negative b over 2a. So x equals negative 5 over 2 times negative 1. So that's how we get 2.5 for that x value. What is the axis of symmetry? X equals 2.5. If we draw the axis of symmetry in here, it's this line at 2.5 where the graph is symmetric. How many zeros are there? Well, I can see that this crosses the x-axis in 2 places, so there are 2 zeros. What are they? X equals negative 1, x equals 6. Or as points, negative 1, 0, and 6, 0. What is the domain and range of the function? So if you notice, the x values go all the way to the left and all the way to the right. So the domain is going to be negative infinity to positive infinity. The range, remember in the range we go from bottom to top. So this graph goes down forever, but it stops right here at the vertex, right? It stops right there at the vertex. So the range is going to go from the bottom, negative infinity, to the top, 12.25. So use Desmos because you can find all those points right in Desmos, the vertex, the x-intercepts, the y-intercepts. So use that and your graphing calculator.